Hi everybody, this is Unit 4, Video 7. We're going to work on rational exponents and converting those into radical expressions, and then we're going to go the other way. So we're going to just start off with a couple definitions. If a is a real number, n is a positive integer, and a to the 1 over n is a real number, then we have that the nth root of a equals a to the 1 over n. So keeping in mind a is real, n is positive, so we're dealing with a positive root, an nth root that is positive, and a to the 1 over n, the result of this is also real. So we get this conversion factor between the two, and it goes both directions. The second statement, if a is a real number, m is an integer, n is a positive number, and the nth root of a is also real, so we're using the previous explanation as well, then we can have a to the m over n can be equal to the nth root of a to the m power, or this could be equal to the nth root of a to the m. So notice there's two places where we can place that exponent of m. It can either be under the radical on a, or it could be encompassing the entire nth root. It could be in either situation. Both are accurate answers, and one may be more appropriate to use than the other when it comes to solving or simplifying when we work with these radical expressions. I just want to also review a little bit of vocabulary with you. We have the radical sign, and our radical sign or the radical symbol is either this or the nth root. Okay? The radicand is the number underneath. So it's the number underneath. And our index is the little n. This would be the index, and it tells us what type of root that we're working with. Okay? And then, of course, we're probably, when we use our square roots, we don't need to include the n. We use a familiar notation that is just the square root rather than the second root of. All right, let's go ahead and try some examples here. So the first thing we're going to do is we're going to work on writing these expressions in a radical form. So you'll have to forgive my exponents don't look so hot here with the fractions, but that is 8 to the 2/3 power. That's what it's intended to look like. I'll have to work on that. 8 to the 2/3 power. So we can write this a few ways. Now I know that many of you want to jump right to your calculators, or maybe you're already processing this in your head, and that's fantastic. And I want to start with some simple ones because you know the results of them, so you know where this is going. So what we're going to work with here is I want to actually take the cube root of 8, and we can do one of two things. We can square it underneath, or we could write this as the cube root of 8 and square the whole quantity. Okay? I think the second way might be better because the cube root of 8 is a nice number. It's 2, and then we get 2 squared, so my final result for A is 4. Okay, for part B, okay, I'm going to take the fifth root of negative 32 and raise it to the 4th power. Again, I'm using this notation rather than raising the negative 32 to the 4th power and then taking the fifth root. I think this would lead us to a more accurate or easier to get to answer. They will be the same result. So my fifth root of negative 32 is negative 2. Now that's still in parentheses, so I'm going to raise it to the 4th power, so my answer will be 16, and it's positive. Okay, we're going to take a look at the next one in C, and I noticed that on B the negative was inside of the parentheses. It was included with that exponent, whereas part C the negative is not included, so that is actually representing the opposite. So when we finish this, our answer, we're going to take the opposite of the positive. If it were included, we wouldn't be able to do it. There'd be no real value because it is a 4th root, and we cannot take the 4th root of a negative number. So we're going to start by leaving that negative over there, and we're going to make this the fourth root of 16, and we're going to cube it. So my fourth root of 16 is 2 cubed, and then I have the opposite out there, so this final result will be negative 8. Now, let's try these with something we cannot just type into our calculator and come up with an answer for. So I'm going to have to work on writing these in radical notation. So this will be the sixth root of x, and it may be written to the fifth power on the outside, or the sixth root of x to the fifth. Both of those are acceptable answers. We will keep in mind here that x must be greater than or equal to 0 because I am taking a sixth root of it. So I'm going to put this extra stipulation in my answer. So it's one of these and then the stipulation, the restrictions on our x. Let's take a look at E. 3x to the 2/3 power. We had to keep in mind what is being raised to the 2/3 power. Is it the 3, is it the x, or is it both of them? For this particular situation, the 3 is not being raised to an exponent other than 1, so I'm going to leave the 3 as a coefficient of my radical. And then I'm going to write this as x squared. I can leave it like this, or I could put the squared on the outside as we did over here in D. I prefer to leave it like this, and I'm going to suggest that we do not need any restrictions on x because I'm taking a cube root where the value underneath, well, it's going to be, it doesn't matter, this quantity will be positive, but I couldn't take the cube root of a negative value to begin with, so there are no restrictions on E. Let's take a look at F. F has a negative 1/2 exponent, and just as we would have done for all negative exponents, we're going to have to relocate this to the denominator. Well, the 2 is going to stay in the numerator, and then I'm going to have p to the 1/2 in the denominator. Well, since our 1/2 represents a square root, this is really 2 over the square root of p. And we're going to go ahead and we could rationalize this. That would be fine, but more importantly, we need to make sure we recognize that p has to be greater than 0. And the reason it's not equal to, as it was in D, because you are able to take any radical of 0, but this has the restriction of not being equal to 0 because it's in the denominator. And even if we rationalize that to 2 root p over p, we still would not be able to put a 0 in the denominator here, so p must be greater than 0. Okay, these are going to look a little different for us. We're going to work with quantities here. So this is the quantity to the 1/4 power. And here I'm going to make the restrictions, or we're going to rewrite this as in radical form as the fourth root of 3a plus b. Doesn't look like we did a whole lot, but we did. And then we're going to make the restriction that the quantity 3a plus b, whatever this value is, has to be greater than or equal to 0. I'm not putting the specific restrictions on A or B, I'm putting it on the quantity that is underneath of the radical. So, in other words, my radicand must be greater than or equal to 0. In this case, my radicand is an expression, a quantity, a binomial. Let's take a look at H. For H, we're going to do very similar things here. We're going to go ahead and take the fifth root of 4x minus y, and we can either cube the outside. If we choose to write the cube on the inside, we need to make sure that we're still cubing the entire quantity. And then we can talk about the restrictions. Are there restrictions on this radicand? Does it matter if this radicand is positive or negative? And the answer is, it doesn't matter. All right, I am going to take the fifth root of this value, so it doesn't have those restrictions as if I were taking an even root. So keep those things in mind. All right, now this page here, we're going to actually work the other direction. So we're going to take these radicals and we're going to turn them into rational exponents. So let's practice going back the other direction. So if this is representing the type of root, then that's actually my denominator of the fraction. So I will have x to the 5 over 4 power. Okay? and that would be the simplest way I could write this. We are still going to put the restriction on here that x must be greater than or equal to 0. Next one, this is the square root, so if I'm going to write this as in rational exponent form, then I'm going to take the entire quantity and raise it to the 1/2 power. It is acceptable to place that 1/2 power on each of these factors. That would be okay. It's also not really necessary. And again, we're going to take a look that y must be greater than or equal to 0 in order for y to have been underneath that radical. Part C. Part C says we're going to take 10 times the 5th root of z, and then we're going to square that. Well, the 10 has nothing to do with the rest of this because it's not being affected by the radical or by the exponent. And then the z is being raised to the 2/5 power, and that's that expression. All right, so let's go ahead now and take a look at what's going on with part D. Again, the 5 has nothing to do with what's going to go on for the remainder, so we're going to leave that. And then I'm going to take this quantity here, 2x to the 4th, and I'm going to raise it to the 7/3 power. In my next step, I'm actually going to apply this exponent onto both pieces of that quantity. So let's take a look at what that will do. It will give me 5 times 2 to the 7/3 power times x to the 28th thirds power. And we're going to take a look and leave our expression like that. Because it is a cube root, I have no restrictions on x right here. X can be anything it needs to be, and this would be my simplified exponent form of that expression. Part E, we're going to take this quantity here, okay, and it's in a square root, so I'm going to have p squared plus q, and we're going to raise that, the entire thing, to the 1/2 power. Again, this is an even root, and it is the radicand, so we're going to take a look at the radicand must be greater than or equal to 0. All right. I'd like you to take a look in your book here at page 73 and give numbers 1 through 14 a try. You'll see that 1 and 2 are matching, and then the remainder of the questions are a lot of just converting between the two forms. But it'll give you good practice to see that you're actually applying the exponents correctly. So please bring those 14 problems to class the next time we see each other, and we will keep moving through this. Have a great night.